All right. Welcome, everyone.
Howdy.
Howdy. Uh, we were just, oh my God, what is this fish emoji thing going on here?
We're just typing woo, but we're getting a fish emoji. And I'm not sure why the other O's aren't. It must be like 4 O's is
That's really funny. Yeah, I don't know. I wonder if that's also like an Eviomix thing because I don't see it in the YouTube chat. That's really
nope. YouTube chat
that's
looks
that's
real
really
normal.
great. Uh, oh my goodness. Yes. So welcome everyone. Yeah, we just had like some internet drop right before the. Oh, there he goes.
Yep.
Yeah, Eric's having a little bit of a little trouble.
At this point, it
Maintaining
might just
connection.
be him doing a bit, though.
It could be a bit. Yeah, that's. I don't know. Eric is kind of like the perfect straight man for every bit. So if he's doing one, it's a. Hey, Brian.
Yeah, I have felt like doing that
found
in
a
like
secret.
important Zoom meetings. Just when you're not prepared, just sort of drop out and be like, "Oh no, and then like rejoin and like stay in one spot for a while, and then just go, "Oh no, what am I
That's
gonna
like the
do?"
equivalent of a mobile phone. Like I'm going into the tunnel now.
Yeah.
Yeah. Cool. Well, do your best, Eric. Okay, he's gonna give it a few minutes. Before that, we were sort of talking about tea, because apparently cream is a secret word in the United States.
Yeah, it was really odd because when we watch TV in Australia, and you put on the local news, and people talk about ordering coffee, and especially because Melbourne is considered sort of a coffee capital in the world. And I don't know how true that is, but we certainly seem to think that it's true. And yet, when I go to the States, I have no idea what it means to order cream in your coffee. And I sort of always assumed that was like a frappuccino with like some whipped cream on top or something. But apparently, it's a different thing.
Yeah. So here I am looking. I'm looking it up now because I want to sort of understand because the effective difference is the amount of milk fat that's in the percentage of milk fat in the milk basically. And so it looks like cream um, is somewhere between 18 and 35% milk fat. And so, like for example, what like, and maybe you've never done this, but what liquid do you use when you make whipped cream from scratch? Is is this something
I,
you don't do
I,
in Australia?
we have made whipped cream from scratch. I probably have to ask my wife, who would know it off the top of her head. I'm not much of a baker myself, but I believe butter and regular milk. I don't know actually what our
Oh, that's
percent
interesting.
fat milk is.
Adding butter into milk could be an interesting way of getting more milk fat into the back
I
into the
guess
milk.
I guess that sort of gets that content up. That makes sense.
Conceptually, like cream is convenient because you don't need a whole lot to sort of make give the effect of. Oh, he's back. Welcome
All
back,
right.
Eric.
Yeah, we'll see. We'll see if it holds. It looks like my connection's a bit stronger now.
Yeah,
so.
you got four arcs.
I had the stream up on my phone, and so I'm a little bit caught up on
Yeah,
the
it's
conversation here.
we're it's the classic the ever conversation. What's what I was trying to say? The conversation we always have. No, that's persistent. Whatever. We're always talking about tea.
Caffeine's important.
Well, I have just never gotten into coffee. It's a little. I have a
A
suspicion
little
that
too much milk fat, do you think? Maybe.
no, it's I actually no. What it is I find so I never got into coffee when I was younger, so I never acquired the taste as you would sort of go, and I can go with like a milder strength if it's got like other stuff in it, like coffee ice cream or something like that, or tiramisu. There's a lot more going on there, but yeah, I never got into like straight coffee, but tea I really really like, and that's terrible because I went 5 or 6 years just caffeine free, and my like diurnal cycle was amazing, and I can't I can't go back.
Anyway, before we have to rename the stream to Tech Audio T Chat,
Well, hold on a second before
I'm trying to move us on.
before we leave that. Definitely recommend Perennial Tea Room for all of your tea concerns. It's Seattle's premier tea spot, located in downtown Seattle, Blake's Place, Post Alley.
For a second there, I thought Perennial Tea Room was in the chat, and they like
They've finally cottoned on to this, and they're like, "Hang on a second, we're missing out."
This is not a paid endorsement. They don't know I'm doing this.
but they
And
will.
let's keep it that way. Secret endorsement. All right, Eric, what did you want to talk about?
Well, how about we
Talk about whatever you-
meander?
Should maybe we should introduce the whatever. Are there new people? Maybe there are new people. They don't know what we're doing.
Oh,
This
yeah,
is
we
just
should say hi.
opening banter. I did update the lower thirds. They stay on longer now, and there's a little bit more space between them. So, you know,
But how do you say my last name?
belt buckles.
Yeah, sure.
Yeah.
Without the belt, though, it's just
Yeah. Well,
No, you have to say the belt, otherwise you don't have buckles properly.
you can say it like inside, you know, and then it's like buckles.
Is that how you get through it? my
It
middle
does
name
help.
is Belt.
One of those ones like in the 90s where film teams were really, really blasé with credits because it wasn't about your writing credits that you came at the end as like the remuneration that you got. So you used to have people putting like Eric the Belt Buckles in his, sound tag or something.
I like the idea of like Eric just being called the Belt as like a nickname, in like an alternate universe where he has a film career.
One of my nicknames
Isn't
used
that
to
this
be
universe? Weren't you an orchestrator?
Yes.
Well,
Right. So what are we doing today? What we're doing today?
Okay,
If you haven't joined Tech Audio Talk before,
Welcome.
we hang out, we talk about tech things, and we
It's
kind of
chat.
we're just chatting about either a thing we're working on, I think someone's working on a new piece of kit or a new thing that's hopping around, and we're sort of trialing this salon format where we're going to show something as well and talk about some problems we have with it or something we need to find out. But if you've got any questions about tech audio, we can probably speak to some version of it or let you know where to find it. So please jump in the chat and talk about that as well.
Yeah, and also with each other. It's sort of like an atmosphere sometimes. There are lots of side conversations that happen in the chat. It's really hard for us to sometimes keep up. Cool. Yeah, I have a couple things to show. I don't know, David. I don't remember if you were saying that you had something or not, or if you were just gonna like wing it, or maybe you don't have anything. It's fine. Eric is underwater on Fortnite stuff, so I'm not gonna.
You have to out me like that to everyone.
Various side projects.
Didn't y'all have like a release recently? I could just say that every couple weeks.
Yeah, literally every 2 weeks. It's every other stream we get to
Yeah, I had a couple. I had a couple things. It's something that came up in one of the Discord, one of the too many Discord servers that I'm attached to. Someone was talking about. Oh, there was a conversation about reusing, like like extending the life of a sample to try to like get more variations out of it. And I forget exactly what they were talking about. They were talking about some, there's like a lot of like VSTs and tools out there that sort of boast that particular functionality. And some of the things that some of the techniques that they utilize are things that are available in MetaSounds. And in if you have the opportunity to use those, there are there are some ways that you can extend the variety or the feeling of variety in your sample content. And so I sort of put together a MetaSound patch of like taking one sample and trying to just with one sample trying to like create variations in the graph itself. And it's a little bit kitchen sinky, and I'm sure it would be interesting actually to hear your all thoughts on maybe other ideas. But I think some of them are probably what we would consider canonical ideas, but just sort of done in a MetaSound way. And then the other thing that I have, which I kind of did a like preview video on, is sort of I've talked about before. I had an idea about how to do that sort of like spline audio component thing, but do it at like a different a runtime solution that's a little bit different than the sort of moving the audio component around the spline kind of situation. So
I think we can start with the first
yeah,
in terms of generating variation. That sounds like it's super useful for Foley elements or sound effects where you maybe don't have a really big pool of stuff that you need to get some variation.
yeah, and some of that to that point is like some of the techniques may be informed by the type of sound you're working with. And the example I gave, which I'm not using this time because that I wanted to go with like a canonical sample, so I've got a boot sample. That's what I've got to work with. But I in the conversation on Discord, I sort of joked about this one time on this gig a long time ago. I had like one Jamaican frog sample, you know, because it's the specific sound this frog makes, and it's just like this is the one I got, this is all I can. I got to figure out how to do this. So no meta sounds back then either. So yeah, let me bring up my screen here.
It's funny, really, because the creativity with those sequences, sometimes it's a good exercise to try and limit your available sample pool and try and generate more ideas out of it, whether it's using a single sample or using a few. But I feel like with the amount of sound libraries available today, you get sucked into this idea that, oh, well, I'll just pull some other variation of a thing out, and sometimes to keep it closer to the source and have a more cohesive idea is generating some of these techniques. So yeah, super interested in this.
Well, and I think another thing is we are sort of trained on this approach to designing variations inside our sort of offline environment. And some of the techniques that we use there are only appropriate there. Like that's the only place that maybe like I think like some people really like sound particles, stuff like that kind of stuff is just kind of unwieldy in a runtime environment and maybe isn't appropriate for us to. But there are ways to sort of extend that sound. But there are some simple techniques that we also employ inside the DAW that could be brought over to the runtime environment to sort of continually maximize the variety. Okay, so here's my boot sample. Oh, and apologies for the frame rate drop. It's just, I don't know what it is about my video card. It just doesn't like Unreal and this Chrome app at the same time. But it's basic. Can y'all hear the boot sample? Did you hear it?
Yes.
Oh, okay. Yes.
Yeah.
I thought it was a billiard ball dropping on a table from a distance.
Hey, hey, this is this is from a library, so maybe it was. I don't know.
Get him, everyone.
So yeah, here's my so yeah, this just is, it's the same thing. But so here's my
Oh yeah. Okay, that's cool.
and part of the tuning is trying to determine how wide you go on the sort of variability of things. But yeah, so let's jump in. And I was very disciplined here. I only used one wave asset input. You can see here, there's one wave asset input, which is my
Might need to go
boot.
full screen for this one.
Oh yeah, sorry, I forget to do that.
There we go.
There we go. Yeah. Okay, so so I have just the one wave asset input. But what I do is I do kind of like a toe heel split, but I do it sort of earballing the time, the time in the sample, because I don't know, maybe I got this sample from somewhere and I don't have an editor handy or something that I could look at to sort of find the transients, right? So I just sort of earballed it, and I have the heel time. So your foot comes down heel first, it hopefully, and then sort of the toe impact after that. And so the heel time is how long for that first chunk of the sound, and then the remainder is the rest of the sound. And the way I kind of did it is I actually just I eyeballed the thumbnail, which was kind of terrible here, and I looked at the duration, which I have the let me go up a little bit, like here. Is that better for people to see?
Yeah, that's great.
So I got the duration of the sound, and it's like 0.165 seconds. And so I started with like, that looks like the thumbnail looked roughly half. So I just started with like a 0.07 as the split point, and then I just sort of tweaked it until it sounded right. And so basically, I just had two wave players in sequence, and one starts at 0 time, and I have an envelope that with random attack and decay times and random attack and decay curve shapes, which we can get a little bit more detailed on those a little bit later. But just sort of the idea is I have this AD envelope, which you can think of as like a triangle envelope, with random timings. But you'll notice is that I actually just do a single random generation for the time value, and then the remainder goes to the other value. So I just basically do a random attack time, and then whatever's left over in the amount of time for the heal is the decay time. And so you'll get this sort of consistent duration envelope where it's triangle shaped, but the two legs of the triangle will be randomly moving all around. So so this and then the curve is exponential or logarithmic, depending on if it's going up or down. And so I have basically on the attack, the curve, I just sort of picked these sort of softer curves, which will be more concave. And then on the decay, also concave. So the reason was that I was getting I mostly just wanted to look at softening the heel, but I didn't want it to disappear entirely. So this heal time effectively is when it stops. So the first wave player will start from the beginning of the asset and play through the heal time and stop. And it will be sorry, I had this oh, I was messing around with this. Okay, well, okay, the envelope wasn't hooked up. So there you go. We'll see. We'll see if that it's okay. There we go. That's a little bit more variation on the heel then. Cool. And then the second wave player starts the wave asset at heal time, and then and triggers an envelope, and then this envelope again very similar, except that instead of 0 to heal time, I am basically setting the duration to be the wavelength minus the heal time. So the range that I have to work in with a little bit of fudge space is basically the rest of the duration of the wave asset. And so very similarly, you'll have on the latter half of the wave playback, you'll get again that triangle with random legs. And similarly, I have a wider range of curve shapes here, so they can be both convex and concave on both sides. And on the attack, that will end up sort of subsuming the transient of the sort of toe, and that'll give like a soft impact on the toe. And likewise, it'll it can soften out the tail of the toe impact. So so basically, I have, and then I have this trigger delay in between the two halves with random timing. It's very, I mean, it's very like narrow
Very
margin.
subtle.
Yeah, but it gives enough of a little bit of like it's still noticeable, and it feels like there is some variation in between the two pieces. So from a timing perspective and an envelope sort of amplitude modulating perspective, we get a lot of variation here. Now that's not all I do here up at the wave player. I also have pitch shift. Pitch shift is our meat and potato variation, but the trick here is you don't want it to sound like a new material or foot, like the or footwear or whatever. So you want to make sure there's a certain amount of consistency. The nice thing about the wave player is the pitch shift is in semitones. So the values, the like whole number values, don't have as strong an impact as with like linear pitch scaling, which is basically a playback factor. So so this was, these are tunables. I felt like I could get away with a little bit more variation on the toe than the heel, but in both cases, I erred on the side of pitching up over pitching down. So I'm not symmetrically around the original pitch, because I felt like pitching down too much felt like it was different. It changed the character a little bit too much for me. So that is something that's randomized on every step for each combination, and so that's another thing that sort of constrains the ranges, by the way, because you still want the both pair to work together. So you get extra variation by changing the pitch of each, but independently. But it does sort of constrain your ranges if you want it to still sound cohesive. So these are there, and then I have volume modulation on each part. So we have shaping through the envelope, but then there's an additional sort of just changing the volume, just randomly giving it what more power or less power. And again, those ranges were something I sort of dialed in for this particular footwear. I think these could all be floated up as inputs for like tuning different samples if you wanted to like reuse the patch. And then here's an interesting part. Then I split the audio signal between a notch filter and a bandpass filter. So a band reject and a bandpass filter, but they each have their own random cutoff ranges. And in order to sort of give I use this random float from 0 to 1, and then I convert it to a log frequency value. And the reason I do this is so that there is a more audio perceptive consistency between the lower and higher frequencies. Because if you just did a regular linear mapping, then you would find you were favoring higher frequencies more often.
Yeah, it'll always be high.
Yeah, exactly. And so this helps sort of make it a little bit more interesting in terms of the variation. And I have both of them going from 80 hertz to 12,000 hertz. And then I just have these two bi-quad filters. Now, the notch I gave a bandwidth of 2, and then I went for half for the pass. And when I play variations, you can kind of see the random. And what's nice is it gives it a kind of resonance. And then because I'm splitting them and recombining them, the like again the pairing creates the independent randomization creates more variation for the same cost. Yeah.
Sounds like you get a little more scuff here and there, So
yeah. It'll that's one of the nice things about pairing it with a notch is you'll get some things will get removed, right?
Mm-hmm.
Or reduced, I should say, because they get recombined, and then maybe the pass will end up boosting some element. Ideally, you'd have maybe more elements to work with content elements, maybe like some gravel bits of textures and things like that. But I really didn't want to do. I really wanted to stay strict to this sort of like one wave asset approach here. But yeah, this I feel like is a very simple way to create more spectral variety without drastically feeling like you've changed the sound itself, right? Like pitch is one of those things where you kind of be careful because it's like you go too far up or down, and then it's like it's little kids' shoes or something, or it's like a giant's foot or something. But emphasizing components is just sounds like you stepped on something a little bit different, like.
So. Yeah, I think that effect works really well. Pairing this with these two filters, the notch and the band pass, is a really cool technique because it means you can do a lot less pitch work, which keeps your upper harmonic structure sort of nice and cohesive to the actual sound source itself, which is what's helping this so much stay the same shoe striking slightly differently. Like immediately when you played it, I was like, oh, it's sort of like a left-right shoe variant kind of thing. And it's like, yeah, it does work because you aren't doing more pitching. I feel like in variation in games, people tend to want to do pitching immediately and they end up needing to shift things and then being like, oh yeah, it doesn't really work that much, and then abandoning it. So this double filter approach, really, really cool.
Yeah, I agree. I really like this sort of. I mean, we've talked about it before. Filters are a little bit more of an expense, but I feel like you get a lot out of this fairly modest use of filters here.
You're trading some memory for some CPU.
Yeah, well,
I mean, like
a lot of memory potentially, right? Like we've got one variation that we're working off of. Yeah, and then the last, I just sort of added some low frequency noise at 20 hertz with 5 hertz rate jitter. So the rate sort of jitters up and down, and then a sort of it's a moderate step limit, I would say, in terms of volume scaling. But this is just a little boost, and it runs. Basically, it just is like a slow noise that just randomly modulates the value, but not in like a predictable pattern, right? It's sort of, it's kind of hard to catch. It's probably not showing up on the stream, but the value is just some sort of random, um, modulation automation. Yeah.
And that's applied over the whole pairing, not
Yeah.
not one heel or toe. It's sort of both.
Yeah, exactly. And what this does, and this sort of approach, I mean, I could use this on potentially other parameters, right? Is it creates a through line that is fairly consistent because you're moving from each update, you're going to have a incremental change from the last. And so so it's, instead of just like a random value that just sort of comes out of nowhere at you, it's kind of like the envelope, where you get a little bit of shaping going on, but the shape is random.
Maybe to illustrate the point, I wonder if you could just plug in a sine input and we could just see it moving up and down.
Yeah.
Because another really cool tech. I don't think I've ever used the low frequency noise node, but that makes so much sense to me.
Yeah, let me just we'll do a little mapping, little pitch mapping. No, not that one. Different pitch mapping. Little float mapping here. And it's going to give me, actually, let me grab its normalized value, and then we'll do something like, let's say 220 to 440. So we get like 1 octave here. And actually, let me just, sorry, let me just save our ears a little bit of pain here. There we go. All right. It's a short sound, right? So it's gonna be a fairly fast occurrence, and you can hear. Maybe I need it more dramatic. I don't know if it's showing up. Do you like that?
I mean, what a cool way to get a little authored shape over any parameter.
Yeah, and we're looking for variation. So random values are very useful here, because I want that sort of like that infinite variety kind of situation. So yeah, that's this is tunable. Obviously, this is control rate. It's low frequency, so it's meant to be sub audio rate. But you can do a lot of tuning here, and then there's some interpolation options. So if if you're okay with steps or not, and it's also supports seeded. So if you wanted like all of the random values, we could insert a seed and then have like our like perfect variation, with like 1 seed value. So yeah, I just have that as sort of rounding off. And also because I was like, it feels a little quiet, because I do a lot of reduction. A lot of what I'm doing here is reducing. And so I found like, I need a little bit of a boost. Let's do a random boost, a little something, a little squiggly automation. So this is, so there's probably a lot more that we could throw at this, but I feel like there's a lot of good material, and you don't have to use all of this. Like I think that you could sort of pick and choose your favorite elements here to And obviously this is a footstep, so that's informing some of the approach that I've taken here, like splitting up into two pieces and that sort of thing. But yeah, so that's my one footstep.
Yay! Round of applause.
Yeah, no, that's great. To put it in my own words, just so I'm making sure I understand, there's two samples, but there could be n amount of samples, and you're splitting the samples at some start time, and then that start time.
Yeah, there's technically one asset,
One
but it
aspect.
has two. It has conceptually it has two components to it, right? Like it's this asset right here, but there's two components.
Mm.
You can kind of hear the two, right? And what this is basically this first component is the heel of your footstep coming down. So like if I let me illustrate with my hands. So let's say you've got your foot. Let's pretend it's a foot, and it's coming down. Your foot is extended outward, and your toes are above your heel, and your sorry, I'm looking at myself in this, and it's backwards, so it's interesting. So then the heel comes down first, and then your toe hits, and this is where you get the sort of impact, the initial impact, and then the slap. And that's the second component here. Is this slap? To go, to go. So that's how I split it. Now, in when you're authoring variations, one of the things you could do is like take your source material. Say you got like a footstep session, and you could take that source material and then sort of edit out all of those components and sort of categorize them. Here's like 5 heels. Here's 5 toe slaps, and then you could use those as the constituent parts, and you could still plug those in and have all of the other stuff here happening, right? You could have 5 heels and 5 toe samples, and then you're sort of maximizing your resources, right? You're not saving anything for anything. you just but you get that like factorial combinatorics of pairing between those two sample groups.
Well, what if you didn't want to do that, but you wanted to have like a large set of assets? What you could do conceptually, maybe this wouldn't work, but like you could run analysis on all of them to find like where their transients are, their times, and then you can map that array and have that in your meta sound. So when you play one sound, you know exactly like when that heel time should be.
I see what you're saying. Instead of trimming them,
Yeah, just keep them all edited this like how your single asset is here.
Yeah,
that would save you a step, and you just run analysis on it like offline, and then have all that data stored inside of the meta sound.
Yeah. And
could you do it at runtime with like a trigger on threshold, and then trigger the other part of it once you hit some sort of level of threshold, rather than measuring it?
Yeah, you could have it be triggers coming in from an animation. So you actually get the real heel contact and toe contact.
William's got a good point. Could you do it off of cue points? Yeah, it really depends on how much data you feel like authoring, really, which is what makes this flexible and inflexible at the same time, which is good.
Yeah. Well, and I think something that I want to sort of extend from Eric's point is you can, because you have control of the start time and end time of your wave playback, you conceivably could have all your footsteps in a single file, and then you're just playing regions of that file at any given time. And it doesn't have to be footsteps; it could be anything, right? It could be your music system, it could be all kinds of stuff. And I think in especially in something like music, I can imagine I mean, this is a very old technique, but like just you have a single file with a whole bunch of music, and then you're just, part of your variation is just like I'm starting at these like these entry points or whatever, and I'm playing like a few bars, and then I'm getting out of there. You can be a little bit, you can have a lot of variation in terms of how long and what are the sort of exit points, and how do you finish, and all that sort of stuff. And so you can kind of go ham in terms of it kind of reminds me. So like, not to bring this up all the time, but I did
Is it the
win
perennial
a
tea
Gang
room?
Award
Oh, okay.
for the yeah. No, I'm getting a reflection of Eevee Mux right here. The the Gang Award for best handheld sound in 2010. Does that age me? For special edition of Monkey Island 2. And one thing that was really interesting about, we were basically on that project, we were given um, MIDI rips from the original game. I was basically just I did a lot of Pete McConnell's work. There were like there were 4 islands. There were 3 composers on the 3 composers on the project. Someone's gonna kill me if I forget. It was Michael Land, Clint Bajakian, and Peter McConnell. I hope I'm not forgetting anyone. But I got Peter McConnell's work, and it was just like here's a bunch of MIDI files. And I had like a loose association with the game level or whatever. And the MIDI files were the input for iMuse, right? Which was the sort of legendary interactive music system. You can look up iMuse, that was used by Lucasfilm Games in their like early adventure games products. And in 2010 was basically when interactive wave files could somehow approximate the power of iMuse from like 1989, right? So like that was pretty advanced in terms of what they were doing. And iMuse was basically able to read and rearrange a MIDI file source from like different bar points and tracks. So I would just sometimes, for example, one of the tracks that I worked on was, there's this scene when the main character Guybrush uh re re-encounters the sort of love interest from the first game, and they have a kind of, he has to like sweet talk her because he's trying to get this map piece that's like stuck in her room. And she's like, why are you coming back out of nowhere, and all this sort of stuff. And there's this the like there's like a dialogue sequence, and you're supposed to give compliments, but there's also like how's your sister doing, and all this sort of like this like the terrible things that you could say reuniting with a loved one. And so the there's basically this loop of music that plays. There's an intro, it goes to a loop, and then there are stingers that are part of the instrumental sequence that sits on top of the loop. And the stingers respond to your selection. So if you say something, that is sort of more of a successful sweet nothing, then you get some pleasant melody. And then if you don't, then you get like a honking clarinet or something like that. And like it was, the file I got was unquantized intro into a loop, I forget, it was like 16 bars or something like that, and with like, it's MIDI, right? So it's like, I don't know, 5 or 6 instruments. And then there was just a list of like, there was probably just like 50 tracks that were just 2-bar chunks, vertically aligned, that was not even part of the loop region, but it was just like over on the side, like the first 2 bars of the track. And it was just all the like stingers. And so and so iMuse is basically this system that's like you can author all of these like things to sort of stitch them together. These MIDI files. This is just a long
I know.
story.
Keep going. What about the story? What are other things you are not supposed to say when reuniting with a lover? It feels like that it was really trying to teach us
This is
something there, and we were like, "What about the
well,
clarinet stinger, though?"
and that was, I mean, it was fun because we were able to sort of, we had some live musicians who were really great, and you can get some like, there's just textures and sounds that you're just not going to get from like a MIDI. And that was a time the MIDI music for video games at that time was very the experience was very driven by the sound card that you had, the sound device that you had on board. And so like the Lucasfilm games composers all had, I think, Roland MT32s, which is like a fancy sample, Rompler or whatever back then. And so then you had like whatever you had on your on your computer, and they
It's
had
funny with the
different.
Romplers because I remember seeing like the Cirque du Soleil setup in the early 2000s was just racks and racks of Romplers ready to go for whatever they needed to play. It's something that doesn't happen too much now because we're just so used to everything being digital. But I do know that there's still a lot of interactive music frameworks that use this approach of linear structures and then having loop points to jump up and back through the same
Yeah.
files. And I know the new wave editor thing does loops and whatnot. So there's all sorts of cue point. It's a very similar structure to that cue point idea,
Yeah.
and using things like that as well. But minimizing that aspect, and instead of it being just music, because obviously we've been talking about music, but this is still the same thing in sound design. You can use a certain transient and play the tail of a different transient, and nobody's going to know if you do it, smoothly.
Yeah. Well, I mean, they might. I mean, say that again. Maybe I misunderstood. They might. They might know. They might hear it.
If you've got a series of footsteps that are all the same sort of thing, and you want to play the transient of one, the body of another sound, like that's a useful approach to sound design. Whether or not how you use it and at what discretion you'll need to apply.
Yeah. Exactly. Yeah. In this case, I like I said, I earballed it, so it became a tunable right for me. And that's something that I made it a variable, but I should have probably made it an input so that again, it's one of those things where it's like, oh yeah, this is always the case. It's like you work on an implementation, you're like, if I went through this again, I could make it usable for other things.
I think everyone says like you got to build a thing 3 times. You build it once because you want to know it's possible. You build it twice because you think that you've worked out how to do it well, and then you build it 3 times because you think that you've worked out how to do it well.
That's Bob Ross did 3 paintings every episode. That's
I think it's a good, when you look at the approach here and you think like, well, like for instance, the filter section that could kind of be its own patch because maybe I'll reuse that functionality somewhere and the specific part of it. But if you wanted to do chaining these sequences together, you're like, oh, I want the pitch shift in this one, but I don't want the pitch shift in this other one because it's like two tonal a variant or something. I could definitely imagine needing to customize the approach a little bit and use certain aspects. But what you kind of displayed here is like 3 different ways to do variation, just sort of wrapped neatly in well, actually 4 really, if you think of the noise, the noise overlay of the scoop, the pitch pattern, the crossfade between the 2 things, and the filter,
and the envelope shaping,
and the envelope. Yep.
And
so
just straight up volume randomization.
It's cool. It's nice that they're all here, and nothing looks particularly expensive, or it doesn't require 18 wave players or something.
Yeah. The filter might be the most expensive bits, but even then, it's pretty modest to have. I don't feel like it's I feel like you get, like I
where
said,
you're using it. It's like if you're using 30 meta sounds that all need 2 filters, okay, yeah, that becomes more expensive. But if this is like a hero asset and there's a player thing, then I don't feel like this is unreasonable.
Yeah, maybe. I hope that you have more than one starting sample on a hero
Nope, just
asset.
one footstep. That's what you heard it here. Dan reckons you can do it with one footstep, so anybody that does 2 is a coward.
Variations are over.
I see the thumbnail now. It's just with fire in the background.
Well, I think I feel like this the bigger picture, or the bigger takeaway for me on this, is there's a lot that we sort of are used to doing offline that we could probably port over to this runtime design. And there are even more techniques that I haven't thought of or covered or imagined, and they might have viable utility in a runtime environment. And so I think this was one of the things that I always felt was like a difficult part of transitioning into using meta sounds from more traditional, or maybe we say classic approaches to game audio, is this idea that you kind of want to bring in the unfinished elements. You want to sort of finish them in the meta sound. And so it's like, and that's there. It's sort of counterintuitive for designers, because there are definitely parts of the finishing process for your design that you do want to do, and that are totally appropriate in the DAW, or you're authoring an environment or whatever it is. But there is a kind of like, if you can leave it to the runtime, then you may, you could go from just having 5 discrete variations of a sound and just a simple random player, to having a lot more variety, a lot more variation, and working with even potentially fewer variations to start from.
Thank you. I totally agree. I think this has given me a really cool idea that we should build OTT in Metasound to do runtime upward and downward compression of sources, because then you have heaps to play with for variation as a different approach.
What's OTT?
Any transient.
What's
OTT is this really popular free plugin. I think it's I don't know who it is. Someone will tell me. But it basically is a plugin that does upward and downward compression at the same time. And so you get a kind of transient and body split that you can use. And people usually use it. It's called OTT because it's over the top. It's tons and tons and tons of compression, and it really smashes sound altogether. But it's a super useful creative tool for making, really hard hitting elements, or adding some saturation on top of something by sort of really mangling the sound. And it is one of those things, one of the points you mentioned there of finishing. There you go. Xfer by will let us know. Is I think they make Serum as well, as the synth, but it's well, I remember it being free. Maybe it's not free. Maybe I've outed myself somewhere, but it used to be free. I remember it being that. Oh, the louder tool, yeah, exactly. That is exactly right. It just slams
TLT, just for your information.
OTT TLT. It is a really useful sound design tool. We're not sponsored by Xfer because I didn't remember who they were. So, but it is one of those things where sometimes this kind of brings up a different point of. I remember someone was asking me, like, should I bake in my tails into sounds when I'm thinking of doing different perspective gunshots and things like that. And the point you made of metasound being the finishing part of the environment is something I do really feel like people miss generally. And you see a lot of metasounds which are just a wave player playing the sound, and that's fine. Not it's here fine. To judge whether or not that's necessary. 1,000 times it's usually fine, and you just like the framework of metasound and being able to see variables and pass things in, and that's cool too. But sometimes people do aspects of their finishing, or if they're making like underwater variations and they're printing underwater variations with a filter, like there's some capability here to do this sort of thing and actually save the authoring time, because I could take an asset that I think like, well, how would this be as a variation? And I could just start in MetaSounds with a bit of a sound after making some variations, and I don't need to commit all my ideas. Obviously, saving state is nice sometimes, but sometimes the flexibility is good too.
Well, and I think that presents a challenge for a lot of the ways that we have traditionally worked. In other words, like there are definitely like a lot of well, you know, Sweet Justice, for example. When we for context, for everyone's information, Sweet Justice, we contracted out Sweet Justice on the Valley of the Ancient project, which was our early access UE5 project. It was like a year before UE5 came out, and I think we released in April or something, like I don't remember exactly when, but like the MetaSound front end started that January. It was like we were working on that project. In fact, I had a poor like this associate designer who had just started up, Matt Fisher, who's awesome, but he was just like he just started with us, and this project was like Zach sort of threw him to me because he wanted like it's a way to sort of get some experience before jumping into Fortnite or whatever. And I had Matt do animation tagging because that's
Yep. Sorry.
Yep. But I had him implement the Foley sounds twice because we did the whole thing in sound keys first. But I didn't want to ship
training, Dan. You trained him well. Look at this. I've got a guy that now knows MetaSounds and sound cues. Nailed it. Good job, man.
I didn't want to ship sound cues. I felt like it's UE5. We're sort of putting a stake in the ground. Says, hey, we're looking to the future. What does UE5 audio look like? And so I pushed really hard to the chagrin of many people. Let me just say, lessons learned. Good designers, good developers get buy-in first before they create work for a bunch of other people. But yeah, so we did everything in MetaSounds. But that was when we were working with Chris on that one, Chris Sweetman, and it was kind of like there was a little bit of like a sit down. Like I had to be like, okay, you're not going to finish the sounds. We're going to kit bash the sounds. And unfortunately, he didn't have access to the build, that's I think the big thing that makes a difference for that. But it was like, yeah, you're not going to finish these. You're just going to give us the elements, and we're going to sort of kit bash everything inside the MetaSounds.
It's such a different framework, isn't it? When you go from games, especially games pre MetaSounds and I mean, we're seeing some more applications of live stuff now outside of just MetaSounds as well. Yeah. But there was a very much like you make the sound as small as possible, and then we play that sound, and that's the functionality. We either sequence a thing and we do it with MIDI, or you make it extremely small and we allow you to play it. So there's like kind of a runtime problem of needing to, well, how many variations am I allowed and all that kind of thing. And now with MetaSounds, it's a matter of, what do I finish and what shouldn't I finish? Because some elements actually shouldn't be applied. It's like when you make a new tool, you can expose everything to values and variables, but then eventually you sort of foot gun it and you go, oh, I've allowed people to make something bad, as opposed to making a more limited tool that actually doesn't have so many controls exposed, but those controls will always sound good.
Yeah. And I think the metaphor of instrument design is really good one there, because there is something to MetaSounds where you're building constraints intentionally in the design, and you're imposing those because you know the output needs to fit within this space, and it doesn't work outside of that, or you know that it's going to sort of rub the aesthetic the wrong way or whatever. And so yeah, I think that, and I actually really like the I've often likened our sort of, well, I should say I come from Reactor. So that's like my graph. I didn't use Max, I didn't use PD. I came from Reactor. And so Reactor felt like the sweet spot for this sort of because they have the graph. They have two graphs actually. They have the sort of instrument, topology graph, kind of like how Metasounds does. But they also have a deeper graph that is just DSP math. That's something that's newer in like the later versions. It's like Reactor 6. But they also, like, you add an input, it automatically adds a UI element. It's like you get this sort of VST front end for free right out of the box. And some people go really cool, like Whoosh and the Twisted Tool stuff. It looks amazing, and so you can get really deep into that. And then from the user's perspective, it supports every kind of user. If you're coming in and you're like a hobbyist, or you just don't want to think about it or whatever, you can just go in, you start preset surfing, you find the thing, and then you start twiddling knobs until you find the sound that you're looking for, and it works. And it's not, because they're shipping with these presets for the most part. There's a lot of variety just out of the box with very little effort, right? You just sort of and then you can go a little bit deeper, and you can just be like, okay, I understand this. Maybe it's a FM synthesizer, and you're like, okay, I understand what FM synthesizer, how it works, and then I can go in and just use the parameters like I would a regular instrument, right? And then you can go one deeper, and you can be like, okay, let's dig into the graph, or let's create some sort of custom functionality or something like that. And so it supports this very wide user base. And from that, you get like this really wonderful community of just like ensemble. You just go on and get a bunch of free, like really cool free ensembles online. And so, yeah, so I think that's like a really good model for, and that's been my reference point for like what I hope Metasound sort of can turn into eventually.
Back to your point.
Sorry, you go.
Well, back to your point about like just making something that somebody makes something sound bad with. There's actually like a lot of value in that, though, like in like misusing tools the way they were intended to be used.
Yeah.
Like for instance, like if what would happen with your footstep thing if you put a different sample in there and started like going crazy with all the different values and like unconstrained some of the constraints you put on it.
Yeah.
So yeah, like there's a lot of opportunity for people to explore and just make mistakes and have something cool come out of it.
Yeah, that's a really good point too. I guess the tricky part is the tool that ships and the tool that designs the tool that ships, and separating those two environments and feeling like the ones that you go to play in. I mean, it's amazing what you get when you accidentally drive a parameter the wrong way. Sometimes you get the effect that you really, really wanted and never was able to find. So there definitely feels like, there's obviously the speaker blowout of accidentally sending a thing somewhere, but that's kind of part of the tinkering and the fiddling. And if that weren't there, we would get a pretty flat VST interface and not have that. I mean, the reactor point was really good too, of you sort of have like this modular synth with everything already plugged in, and then if you look around the side, there's like a sidecar of all of the really complicated stuff, and you're like, oh, what's happening here? And if I rewire some stuff here, and you look around the back again, and there's all the electrical components that you can kind of swap out the cards for or something. And I mean, I haven't looked at Reactor in ages, and I remember it feeling overwhelming initially. But you're right about the community. Whenever you find a community space where people are, it's simple enough that people getting into the complex stuff can just kind of get really into it and give you all these variations. Always felt like Reactor was really good at that. Like presets in Reactor never sounded like anything in any DAW. Like I never opened Logic and hit some presets and got a Reactor sample. It was always very like musical sounding instruments, which is obviously the point of the composition framework that they're going for. But Reactor definitely feels like the synth playground of the modular synths you couldn't afford, sort of thing.
Yeah. Huh. All right. Yeah. So we could, I don't know, you want to switch, should I switch over to the other thing that I had? Did I already say what it was? Yeah. Cool. Yeah. I'm glad we got like kind of a nice robust chat out of what is ostensibly a pretty simple demonstration. Yeah, so again, I apologize for the frame rate drop. Once we go 3D here. Oh yeah, let me let's go full screen. Oh, I forgot to make the editor. Okay, hold on a second. Here we go. Hold on.
I'm holding.
Hold on.
Hold on.
As a reminder, you can go to your editor preferences and go audio.
And
allow
turn it
background audio. Turn it. And then you CPU, and then make sure that this is false. You don't want to use less CPU. You want to use all the CPU. Okay. So, yeah. So here's the. I guess well, my frame rate's terrible. We'll just switch over here. I think the audio is fine, but
yeah,
we'll switch there. So let me actually I'm going to eject here, and then I'm going to go there we go, into my water, and I'm going to turn on the debug. Oh, it didn't like that. Okay, maybe it didn't like that. I mean, I didn't support runtime debug switching. Okay, let's. Here, I'll go in here, and then I'll switch. So here's my my river spline. Sorry, I forgot I was like talking about a whole bunch of stuff here. The river spline, and I've added my own component, the SC sound spline component. I did everything in blueprints this time, so hopefully that will make people happy. And then here are the parameters that I can work with, and I've got sample width, and I've got spline name, so if it can support multiple splines, it can switch between ones. And then I have this debug flag, as you do sometimes in blueprints. And then I have my sound source. This is the meta sound that I'm actually going to use. And then my fall off distance and my inner radius. And the reason I have these settings is, once again, I'm using I'm sort of simulating attenuation inside the meta sound itself.
Excuse me.
That's fine. And so let me hit the debug. So the gist of it is the gist of my approach here, because we were talking, the sort of canonical. Sorry, maybe I'll just this sort of canonical version of this problem. And for people who are maybe new to the chat, the issue is you have this spline, which is defining the path of the river. The spline is just a curve in space. And you have the spline, which is defining the path of the river around the level. And we want a sound to sound like it's coming from the river. And so a traditional approach, and when I say traditional, I mean like in UE3, this was a thing that you could just add to a level, is to have an audio component, which is basically the handle for your sound source and representative of the sound source's location, and have it update its position along the spline. And this works pretty well, actually. You can traverse most spline shapes and feel like the sound is coming from the center of the spline, basically the white line curve, this curve here. And so the like in that case, the audio component would just sort of slide along the curve as you moved around, picking the position on the curve that was closest to the player, the listener, the camera, whatever. And so that's cool. But the problem is if you think of a spline from beginning to end, it's like winding all around the space. You think of the spline from beginning to end, and think of like position along the spline as like a 0 to 100% or something like that. And so you can think of like, oh, it's 50% along the spline, or if it's 30% along the spline, you know. But in space, that doesn't translate necessarily to a straight line. It's winding all over. And so if we look at this curve, we can see, you know, let's say this point over here is the beginning, and this point over here is the end. And if our audio component is supposed to slide along our spline, you know, it would traverse, ideally would traverse down along continuously, but it may have to jump if, for example, I'm moving from this close to this part of the spline to this part of the spline. It's going to have to jump to, you know, 1 to maybe 10% to like 90% to 100%, right? It's going to have to jump. And so what you get is these situations where this very natural river formation can create problems. It's like the most realistic river formation you've ever seen in Unreal.
And this issue is because you only have one audio component on it, correct?
Yeah. I mean, you could say that, but what do you do with two audio components?
Right. Yeah. No, I'm just
because the closest point is still the closest point.
Mhm.
Right? And so right. So this is the problem: is when it sort of curves back on itself, it's going to jump from maybe left to right, which could sound weird, right? It could sound unnatural. And then there's also larger problems with like large sound sources, like a river, and how sound propagates with those sources. And so the last time we visited this problem, I experimented with something called distance fields, which is spatially I encoded in the field the sort of a like spatial hash around the spline. I encoded the distance from the spline. I just sort of grabbed the closest distance. So it's the closest distance conceptually, but it allows me to create as a uh, uh, lookup interpolation between these sort of jump points, basically. And part of what I did to make a more dramatic tilt to the sound was I sampled the space around the listener, the spatial hash grid around the listener, much like sampling maybe like a sound field. And except I don't know how to do sound fields yet, so that's what I'm saying. So I just did sort of like this weird, you know, cube of like 20 something cubes around the listener, and then I gave a sort of approximation of magnitude for the left and right sampling. So that's how I approached it, which is very heavyweight to generate the spatial hash. It took some time, especially if I wanted a more detailed hash. I had to do like oversampling on the space itself to get to avoid holes and stuff like that in my sampling. You know, when I was tilting in weird ways and stuff like that, and so it had lots of issues. I think it was a fun experiment to sort of explore encoding spatial data inside something like a spatial hash. So you can walk around and sample and get information from the environment that way. But I sort of conceptualized. I don't remember. It was like maybe it was while I was presenting on it. I had the idea, or right before, or something like that. You know, when I was wrapping it up. A real-time approach that was much simpler, much cheaper, but only applies to the spline scenario. Because the other thing is that the distance field, also I could generate distance fields on static mesh shapes and stuff like that. So, I think there's still interesting. That's still an interesting space to explore. But yeah. So the approach that I've taken here is I have an audio component, but I don't move the audio component. I play the meta sound non-spatialized, and then I simulate spatialization inside the meta sound.
Heresy.
Heresy. And instead of a big distance field that I'm sampling, I am taking the approach of sampling width to then check the nearest location from 2 points, the left channel and the right channel. And so in this case, if we look at my sound spline properties, I have my sample width as 250 units. So I'm basically starting a probe 250 units from either side of the listener, camera in this case, because I'm using blueprints. And then I am checking the closest distance on the spline to both of those. And then I'm feeding the distance value that I get from that result into a left distance and right distance parameter in my meta sound. And then I have a sort of function in the meta sound. We'll take a look at that, where those values then basically attenuate the sound. And so yeah, and so let me add the debug, and you can kind of see what's happening. So you can see here I have basically I don't know if it
Can you enlarge it again?
Sorry. So you can see the frame rate's fine when I'm not in the editor, which is really weird. So you can see that I have a line trace on the right side of the screen, and a line trace on the left. The right side is orange, the left is sort of cyan, and then there are two spheres, red for right and green for left. And the two spheres represent the two closest points on the spline for the probe locations, which are extended out from the camera left and right, basically.
And we're sort of shooting these forward like a TIE fighter. Those are straight lines, not actual angled lines or anything. Yeah. They're actually going straight, but the view of the camera makes it look curved.
Yeah, and actually, if I eject from the sorry, I was ejected. Sorry. If I eject, you can actually see. Oops, there we go. You can see my like probe start points.
Wait, does that leave the camera listener where it is? How come it's not moving to your editor?
The camera, well, I'm not. Well, this is a distinction. Because I did everything in blueprints. I don't actually have access to the listener transforms, so I'm using the camera transforms.
Gotcha.
And those are part of the camera manager access. The camera manager access is still on the pawn.
Right.
So this sphere that you see, this is the pawn. There's the default pawn.
Gotcha.
It's my little person. It's just, if you use the, I just use the, where are my world settings? It's like the game mode base. Like the default game mode gives you like a little camera pawn that you can fly around.
Gotcha.
And that's what that is. So if I repossess, then I'll be back in the position here. And so the attenuation that you hear is based off the data that's collected from this evaluation. So in other words, I'm doing 2 line traces, or rather 2 distant. The debug is with the line trace, I should say. I'm not doing line traces. Apologize. I'm doing 2 distance checks instead of 1, and I'm doing 1 for each ear basically. And the sample width allows me to create a kind of exaggeration of that of that that sampling, that value. So, for example, if I went in to
This
my
feels like this
river,
would be way cheaper than distance fields.
oh yeah, definitely. So here I could drop the distance to like 50 units, it's like half a meter, and and then you can see the evaluations much closer. It's kind of here. It's hard to see the left and right, but you can see the distance. The left is like maybe well, I guess you could expect 100 units closer than the right because I'm sideways there, and I just marked it as 50 units. So two times 50 is 100. There you go. But but that's just so that becomes a sort of like, how strong do you want to feel the tilt basically between the two ears. Now, there are a few, there's more that could be done here. I've considered like adding in height as an example for some of the layers, because I actually have 3 layers. I have a sort of distant, medium, and then when I get really close, you can hear some detail ripple sounds.
That's great.
Yeah, and those all, a lot of those, that tuning there is, in the meta sound in terms of how I'm feeding in the data. So yeah, so any questions before I dig into, I don't know, should I start with the blueprints or the meta sound?
I think maybe the
No, we'll start with
blueprint.
Blueprint.
Yeah. Cool. So here's the component. And it's mostly commented. It's kind of comment. There's some comments. There's 3 comments. Not bad. Okay, so testing my memory. So I'm hearing myself. Am I?
Sound
Did
good?
that bleed on someone's headphones or something?
I leaned in. It might be my.
Oh, that's it. Oh,
trying to read these comments.
We were in
sorry about
trance.
that. Yeah. So on begin play, I look for, this is the sort of thing I was talking about where I could select which spline component I wanted to base this off of, and so I just go through the owner's spline components, and then I just go. What am I doing here actually? Oh, I'm setting it if it's match, and tough cookies if there's a collision. That's on you.
Fair. Maybe it is what it is. Sometimes it's your fault.
Then I cache the component, I get its owner, and then I add an audio component as an attachment to that. So basically, this component is managing the attachment of an audio component in runtime. So it's not like a member component on the actor. This is a component that I want to be able to add, and then it's going to basically manage its own component.
I have a really dumb question about this. Add audio component versus spawn audio component, or spawn attached, or something like that.
It's a great question. Yeah, so add audio component. The add, when you see add blank component, that was auto-generated. That function was auto-generated And so what it's going to give me is like a completely clean audio component with no parameters set on it. If you do something like spawn 2D component, then it's going to set a bunch of flags and parameters on that audio component as a convenience.
Gotcha.
And so in this case, I am literally just adding a raw audio component. This is sort of like one of those use at your own risk kind of situations, but it can be very useful if you know what parameters you want to set on your component. And one of the things that I find in particularly useful about this is if you want to build a component pool, then you want to manage all of those parameters yourself. You want maximize control over the flags and stuff like that. And so this sort of raw add component is usually how I start building one of those. And so I'll specifically set all the parameters I need to be set, because I want to set those for whether I'm adding a raw one or I am reusing one. Because if I'm recycling an audio component that already exists, I need to set all those parameters differently anyways, right? I don't want to like have vestigial parameters sort of creating weird instancing on my sound. So
yeah, right. Yeah, I guess it's that thing of like needing to I mean, pooled systems are notorious for some state being corrupted somewhere and someone
some
forgetting.
State lingering because the bool didn't get set or something, forgot to do. And so this way, sort of, it's like it forces me to manage those.
Yeah, right. Because it's sort of the raw configuration step as opposed to something that may be set in a drop down somewhere that, okay, yeah, great. Awesome. Thanks for that.
Yeah. And so, yeah. And then you see these, all these are the parameters that are actually just part of the scene component, the parent object of the audio component. But if there's a U property that has like an expose on spawn flag, then it'll appear here as well. So then it gives me my raw audio component. I just cache it. So now I've got it. I'm just using the one. And then what I do is I also cache the max bounds of my so this is actually something. Let me put this. This is an unfinished component. This or element of this design. Basically, this is how this plus the fall off is how I would manage the activation and deactivation of my audio component. But I didn't get around to it. So in other words, if I went far enough away from the spline, I need that to stop. Basically, deactivate the audio component. And then when I come back in range, I needed to activate the audio component. And so, so what you want to do is you want to get the bounds of the spline component, and that'll give you world vectors of the max vectors and min vectors, and then you can do something like a very simple like add your fall off distance to each of the values to just sort of push the vectors out, and then use those as the like boundaries in which you could activate or deactivate that. So when you go outside of that, then it will have already fallen off. Like it will, because we're not using the spatialization to manage the voicing, right? So we're sort of handling that ourselves. And so that was the idea behind this, but I didn't finish it because I had not at the time implemented like all my distance stuff. And so so I have inner radius and the fall off distance, and I would just add both of those to the max bounds and subtract them to all of the min bounds to each of the vectors, just to keep it simple. It's fine if it's like it goes a little bit long in the diagonal. It's fine, but it'll basically create like this big cube around your spline that then you can decide when you want to activate and when you don't want to activate it. And if you were going to go extra mile, you do things like some sort of like you could implement like a very simple timer for virtualization testing, that sort of stuff. Cool. So yeah, then I set the sound on the component, and then I call the update function, which does this so I can get the initial values loaded onto the metasound parameter interface, and then I call fade in. I just do this helps with sort of like parameter bursts to the like initialization. It's nice to have a little bit of a fade in, just to smooth things out. And then I set the spline as active. And active is just used on the tick because I am updating on the tick. You could amortize this, and then you would have to smooth out things and do some interpolation, that sort of stuff to sort of. But we're already saving the company a lot of time switching from distance fields. So, come on, give me that.
We can do it later.
But it's very simple. I just do a branch. But if I want to be a little bit more active, it could be like activate tick and deactivate tick and all that sort of stuff. You could go really, really detailed on tick management. Or again, if you just want to hide the fact that you're using a regular update, you just go to a timer and ignore tick entirely. And then that
feels like we could do a whole several hours, several weeks on tick management and everything. Yeah. And we probably should at some stage. We should just take some bad components and go through optimizing them, because it feels like tick is where all of the prototype ideas start and usually not where they end.
Yeah. And then I just call update, and the update function basically this is where I had. This is the thing that I spent the most time on, which is absolutely not where I wanted to spend my time. But it's getting the correct rotation from the camera manager. That was very painful. It was unnecessarily painful, in my opinion.
So you can't just get closest listener?
Well, that's the thing is I need rotation from the so I need basically the listener transform. So this is one of those things. So it's like, we just need like a function that you can call for blueprints, like give me the listener rotation or listener transform. Listener right vector, because basically I'm using the right vector for the left and right. So I take I get the camera manager, and by default, the listener is attached to the viewport, the camera manager. So the camera should have the spatialization, and then I get the camera manager as an actor, and so I get the actor location, and I just go to cache it as listener location. Oh, I guess first I'm validating that spline component still exists. Always validate your components, or your object references. And then I get the the actor rotation, and then I invert that because the camera is, I believe, swiveling around inverted. It's behind the pawn or something like that. It's the way that it works. And so I was getting this like inverted XY like horizontal behavior that was just like killing me. So I invert that, and then I combine it with the camera rotation, which is the rotation reported by the camera manager of the camera, which is not the same as the actor. And so the actor rotation inverted basically stabilizes the whirl, the rotation, so that it gets sort of world locked. And then I use the camera rotation from the player camera manager, combine the rotators, and then that becomes my rotate vector for the right vector. The right vector is where I'm going to do my sample width, right? So if we're pointing in a specific direction, I need the vector that points to the right of us. So positive times that vector multiplied by my sample width, positive and negative, will result in the right and the left respectively. So I cache the listener rotated right vector. So I have its location and the right vector off of that location. This is normalized. This right vector is going to be normalized. So
You've just
you
saved
can
us a
then
lot of time, by the way.
I did?
Yeah, figuring out all this stuff.
Oh,
would have been a
yeah.
nightmare.
This was basically, I spent way too much on this bullshit here.
Just the difference between the actor rotation and the camera rotation.
Yeah, exactly.
Like, yeah.
Because there's like 3 distinct problems for anybody that's done rotation stuff. One is the quaternion flip, where if you take quaternions, those rotation values, and people will usually try and make them vectors and say like, hey, why don't I just use the vectors instead? And then they start using them, and then it goes to -180 and back to 0, and it jumps, and you end up getting like, I've used these for physics before, and then if you make them into vectors instead of quaternions, you end up getting these enormous velocity spikes from something, because it believes that like, hey, last frame I was here and now I'm 180 degrees out of the way. So that's definitely something to be aware of here, that with rotation you kind of do need to work in these really funky rotators instead of vectors, even though you could drag off that and turn it into a vector. Please don't, because it just doesn't work. You need to kind of go through this way. And then the other thing that you've got there that I thought is just worth dovetailing again is that get actor right vector is kind of like an orientation vector, so that we have a way to know which way was right, because if you're turning around and up and down, we can't always look at forward, for example. We kind of need the orientation vector of the one that's pointing at the degree, so that we can know which way is forward, which seems counterintuitive. You would think that, well, use the forward vector, but then you're going to you end up going to be off axis no matter what, because you don't know which way is to your right. So for everybody that hasn't used things like get actor right vector or forward vector or up vector, that's the way that we have an orientation vector to point in the right direction.
Right. Yeah. So there are 3 orientation vectors: is up, forward, and right. And so those will give you stabilization around the 3 axes, right? So you know your sort of orientation on those. So in other words, the right, like as David said, the forward vector, you could roll the camera and the forward vector would stay the same. And you're like, I'm doing barrel rolls, but but you don't know what's right anymore. So and you don't know what's up. So yeah, that's the
Interesting
idea here.
moral questions, really. What's right?
What is right, or what's up? Yeah. You'll never think of the question, "What's up?" Again. Okay. So then I do. Is this one of my functions? Oh yeah, it's one of my functions. Cool, neat. Okay, so yeah, see here, I have left is I have the spline component. I have the listener rotated right vector. I have my sample width, which I multiply by -1, because I want to take that right vector and go left. I want to go reverse. So I'm going to scale these 2 together, and then I have the listener location. And then if we look at what I'm doing here, is I'm just scaling the right vector with the sample distance. So I'm just multiplying them together, and then I am adding the listener location and the right vector. As I said before, the right vector is normalized, so when I scale it, it's going to give me the sort of relative coordinate, assuming a 0 origin. And then when I add that to my listener location, it becomes a world coordinate. And then I have the find location closest to world location, which is a spline component function, which intakes a spline component reference and the world location or rather, you could switch to local coordinate space, but I'm asking for the world space. And then I spit that out as the spline location, and then and that is really for debug. I'm just using that value so that I can use it to place those debug spheres. And then I am um, basically taking my my starting point and my ending point, and I'm subtracting the starting from the end to give myself the vector between the two. This is like your classic AB vector. And then I am getting the length of that vector in a scalar value. So it outputs a float, and that is the distance that I want to use. And so if we go back, we can see I'm just sort of caching those values for graph cleanliness. And I have the left spline location and the left distance. And then I do the exact same thing for the right, except of course the sample the sample scalar is going to be positive instead of negative because I want to sample along the right vector, not the left side of the inverted right vector. So and then I do go through the same thing, and I get the right spline location, the right distance. And then I have my draw debug, which I just sort of sneak behind a little flag. This, by the way, not good to ship. This, they hate this. They don't like these. But it's very useful when I'm working on it.
Who are they? Who are they?
Yeah, who are
being
they?
Yeah,
Just
who are they?
Illuminati.
Who
Just
are
what?
they? And
I don't know. I mean,
so
it's better than just leaving it, right?
yeah. So and I had 6 debug elements when you saw that when I was when I had depossessed the pawn. I had the 2 spheres for the closest location on the spline. I had the lines and the spheres for the sample points. And the reason I had these last 2 in particular was because of all of this shenanigans. I was like, I can't figure out why this rotation is wacky. And so it helped to have like those spheres off the side of the ears. So I was like, okay, this is where I'm trying to sample from and all that sort of stuff. So that's what this is going
Rotate
on.
the camera. If you rotated the camera, not turning it, does the math still work?
I welcome you to try.
Do a barrel roll.
Yeah. I think it probably breaks, but it's fine because nobody. The only time that it'll break would be if people do that weird poke out when you poke out the side in like an FPS and they tilt the camera on that axis.
Yeah. Hey, look, y'all. If you come up with a better solution, post it in the chat or something. I don't know. Like that's please fix this for me because this I find really convoluted. And so I would like to know that there was a dumber, simpler situation. With that said, I think I cannot reason why we wouldn't want maybe some helper functions to grab audio listener transform data, even if
I
it's
think
just like
two parts really. We want audio listener transform data just for the sake of being able to just debug, show it or something. Like besides I know there are some show listener stuff, but that works. And then the other thing would be just some math functions for getting these orientations does feel like handy.
Yeah, and and like a lot of situations where you're grabbing listener transform or camera transforms, this gets complicated if you want to support robustly split screen, right? But in this case, I'm grabbing the 0th camera manager, which I'm assuming is going to be like the first player who is the winner in all things audio. And then I feed in to my meta sound. I validate my audio component, and then I feed in. I could probably also actually, would be good is to also do a check on is playing. Since you don't want to like needlessly
Does is playing fail if it's virtual? You could probably check his virtual as well, or is not virtual. Is virtualized maybe? Yeah. Because that's a good point. Like if you have expensive functions,
Yeah.
aren't always going to be playing, then this kind of behavior is pretty useful for you it just gives you free optimization for nothing.
Yeah. This is and I think also it'll yell at you sometimes if you're like, oh, there's no sound playing, and you're just trying to stuff it with parameters over and over again. So yeah, I left distance, right distance, and then I pass in the inner radius and fall off. These could arguably be constructor inputs, which only get set at the instantiation of the audio component playback. But that's sort of like another optimization detail to potentially use. Right now, they could be potentially dynamic. Cool. So that's actually all the blueprints. Not too bad.
Yeah, looks nice.
Easy.
Yeah. So I don't know. Do y'all have questions about the blueprints before I migrate to the?
I think it's good.
I think the meta sound will be pretty straightforward. Here are the what do I have? Oh, I do have like just some ambience, but I actually pitched it down a lot so that it by like an octave or something like that. So it's pretty subtle and out of the way. But I just wanted like a non-digital silence noise floor, basically. And then here's the distance. Pretty decent. The medium, which has like some sizzle. And then the close-up is actually just a like smaller ripple type layer, which I find if you can get the volume mix right, feels like it's just a natural detail layer on top of the more washed river noise layers.
Mm-hmm.
And were you using attenuation in this at all, or is it attenuation by? Okay, yeah, cool.
It's all simulated in the meta sound itself.
Yeah, nice.
So I have. Let me Let me let's do this. We'll isolate the bits. So so here's the oh, this is, I guess, this is the distance layer. And basically wait, hold on a second. That's what I'm missing here. Probably this oh, this is, hold on a second.
It defaults to 0, it looks like.
It should be 1. So this is 1. And here we go. I think this is the issue here. So the inner radius, let's say, is 500, and then the fall off is like 5,000. Yeah, here we go. So here's the like when the left ear goes distant, you can hear basically the attenuation, and so that's basically what is creating the attenuation. It's just the differential between those two input values, and then that is intensified by a power magnification that because this is a 0 to 1 value, the more intent, the higher the power value, the more you'll get like a smaller number, basically. Or the more intense, I guess, convex the curve is from 1 to 0. And so if you want like a milder differential, and so this all comes down to your sampling, your sample width, effectively, because the max sample width would be like a direct head-on from like 90-degree angle to the listener. So, if like you were just right facing the spline component, your closest points would be at the same spot, but you would have like, say, the right one would be closer by the sample distance times 2 from the left one. So this stuff requires a lot of tuning.
Sorry, Dan, you just lost me a little bit with that last point, and it feels like a really important one. Can you go over that one more time?
Yeah. So imagine you have your, the sample distance from our blueprint is basically extending out the distance evaluation from the right side of the listener and the left side of the listener, right? And I mentioned before, you could sort of exaggerate the difference between the two values by making that larger, like the distance larger.
Yep.
But it's the same as this intensity value, right? Because you have this is the actual distance coming in. This is not normalized. I am using the inner radius as the starting point and the fall off as the ending point to normalize these from 1 to 0.
Mm-hmm.
Right? So I've got a linear map of distance. And so if I'm inside the inner radius, then I'm below the starting range, or I should say, before the A starting range. And because it's clamped,
it's at 1.
It gets stuck there, right? Yeah, it gets stuck at 1. And so it doesn't go over 1. And then once the distance is past the inner radius and I'm between the inner radius plus fallout, right? So if it's like 500, then the max distance is like 500 plus my fall off distance, which I just put a 5,000 as like a sample here. And so if it's 500, this is the max distance is 550, 5,500. And so, so between those two ranges, I'm going to be going from 1 to 0, right? But it's a linear traversal. The distance mapping is linear. And then if I go beyond the fall off, I just clamp at 0. It doesn't go below 0, right? So the intensity, this power function at the end, magnifies the curve. And what that does is instead of a straight line from 1 to 0, you get this concave shape that goes from 1 to 0. So what that means is if one ear is at 50% and one ear is at 55%, then there's like on the linear, there's like the 5% difference in the sound amplification. But as I increase the concave shape, you'll get a much more exaggerated differential between them. But they'll sort of like, there's like a midpoint where they get maximize that differential and they sort of even out. And so that's what that's why I call it intensity.
It seems like a super useful control for specific types of effects as well.
Yeah. So here, let me go real low here, and we can just sort of listen. This is, you can see there's almost 1,000 units difference between the left and right. This one's at 2760, and this one's at 1632. And so when I bring the intensity up, you'll start hearing it tilt toward the right because the right is closer. Yeah. So this becomes a tunable for determining the spatial exaggeration of the layer. And I have that for each layer. So, like for example, oh, I guess I didn't have it for each layer. Fuck that one up. You can have it for each layer. Just use the same parameter. You can tell I got a little tired on this one, right? so potentially I can have a different
Don't scroll down. Don't worry about
it for each layer. What I did do, however, is I changed the mapping, right? So the medium distance mapping. Switch these over. I'm all about that alt click now because after Eric showed me that.
Life-changing.
I know, right?
To disconnect nodes?
Yeah. I didn't know about it. He's still learning all the time. So here's the medium layer. This one is basically starts at the inner radius, inside the inner radius. So it still attenuates even when you get to the inner radius. And then the fall off is half or 50%. So it basically sits. It's a little bit more narrow than the wide, and it falls off a lot faster than the wide. And also let me see. Oh no, I did. I have it at. I ended up going with the full volume here on the final mix. But this layer I could probably improve in terms of getting that detail to pop out. That was where I was talking about the intensity, making different intensity settings for each of these layers. But that's the sort of medium layer. And then here's the close layer.
It does make sense that that they would have slightly different, spatial profiles, considering you're so much further away or closer. You probably want that effect to be more dramatic or less dramatic.
Yeah, exactly. So here we're outside of the inner radius entirely, so it's silent. This is the close detail, and so I gotta get into that inner radius, and it's just I go from 0 to inner radius, so it basically is just shaped right outside just inside the space of the river. And it gets more intense the more you're sort of like centered on the river. And yeah, this is obviously it's a much smaller stream than what is characterized as the other elements, but from a layer perspective, when I got the mix right, the blend right, it felt like a nice little detail, a close detail that sat on top of all of the values, all the layers. Sorry. Wait, is that the right one? No, it's mix them up here.
The sound effects, guys, another great tip if you haven't seen that. If you shift click each pin to connect them instead of dragging the cable.
What is this? Shift click?
Yeah.
Oh, neat. Hold on a second.
Nice.
Where is this? Let's make sure this. Yeah, there you go.
So good.
Yes.
Now the only one I really need one for is when you drag a cable out, which I guess I shouldn't do, and you slightly miss the pin right at the end, and then you get the meta sound thing. But then sometimes if you click the cable anyway, it will click. It will connect in the end, which I think maybe means that if you are dragging a cable, you accidentally miss and open up the window, but then shift click the pin, it will connect and you won't need to click out of the window and go back again.
Got lost in that sentence.
That's fine.
I'm gonna start shift clicking though. That sounds nice.
Workflow acceleration, right?
Dan, try shift clicking audio to float, for instance, just to see if it
Wait, what?
pops up with like
What are you talking about?
shift click from an audio output to a float input. What happens?
What are you
Will
talking
it
about? What are you
Oh,
talking? Get out of here.
all right. Let's see what happens. Yeah, okay.
does it pop up with the conversion? Or?
Wait, did I do it
I
right?
hope it doesn't
Shift.
crash. You got
Oh,
to
it's
hold
already
shift.
connected. Sorry. Let's do this. There we go.
Oh,
Ah,
baby.
yeah.
Oh, baby.
I guess that's just the same result of doing this, right? And that's
Yeah, I guess.
yeah. All right, cool. So, what do y'all think?
That's nice. I really like it. The only thing I would change is I feel like the intensity should be a 1 minus because I feel like turning the intensity up and getting less of an effect is a weird heuristic. But otherwise, super duper duper cool.
I guess I was thinking of the intensity of the difference. That's not how I was thinking of it.
Yeah.
Yeah.
Totally makes sense. I love it as a control. Super, super useful. And the multiple layers thing. Just generally like being free of attenuation and being able to do your own version is really powerful here. And I think you've figured out a great way to actually show how it's useful as opposed to it being a cool thing that you can do in meta sounds. But then you're like, why would I do that instead of attenuation? Like this is kind of the only way to do this behavior is with Blueprint and manually doing this.
Yeah, I think I agree. I think I mean, you could have, 3 different audio components, and then each one have its own attenuation. But that is, I don't know.
That's its own got drawbacks.
Yeah,
as well,
exactly.
so.
Yeah. Cool. Well,
thanks for sharing.
All right. Yeah. I'm amazed we were able to we had a pretty good chat actually about all this stuff. Yeah, it worked out.
I didn't have high
I
expectations.
was worried we'd get through everything really fast, because it wasn't actually too complicated. Everything wasn't. What is this?
Well, it's not complicated for you, but some of this stuff is tricky. I think actually the thing that makes it not complicated is the fact that you have thought about the complicated bits and you're presenting the solution part. Whereas some of those parts, like actually doing them, requires like rerunning the game 30 times to try and work out what the values are. So having something where there's a bit of a blueprint to or a plan to follow makes talking through it a lot easier because we can kind of see the finished result and then be like, oh, okay, that does this and this does that, and that's the connection.
Well, I definitely went more than 30 times on that camera rotation.
Oh, man. Especially because the debug numbers just don't mean anything to you. Like, when you're looking at the pins and you're like, oh, I'll breakpoint it. And then you're like, I don't know. Is this good? Is this bad? What's the number supposed to be?
Yeah, that's where I got that's why I had to go with the draw debugs and it was even then it was finicky because I had to depossess to see, I mean, you could only get so much because like sometimes I'd be like, oh, all right, and then the sphere would just sort of cross like transit across my field of view, and I'm like, why is it moving with me? It should be moving the other way, like what's going on here? Yeah, and then you're not sure because it's also like a combination of function calls and rotations and related elements, and you can't really audition without the result being the sort of end point of those values, and so then it becomes really hard to. You get, especially when you're tired, you get into that mode where you're like, oh, let me just try this other one. Let me just try this other one. Let me just try this other one.
But also, like, you need to have all your ducks in a row to get any result that's worthwhile, which is what is also tricky because you could have a thing. Maybe I guess at the blueprint stage, you could just have some sort of normalized value that you were looking at that said the volume, but it's hard to like discern whether or not that actually sounds good until you plug it into a meta sound and then hear something, which requires some more finicky stuff, which then it's like, is the bug in the meta sound or in the blueprint or in the which sometimes, when you're standing up lots of systems, trying to think in terms of a small fragment is handy, but also it sort of gets down to the point of like, is this correct or does it need to be a certain value later on?
I did start with one layer. So I basically worked through building the system with just one layer to keep things simple. So I just had like, I think I just had like a distance input at first. And it was just like, actually, I should say this. I did the first bit without sound. So the closest spline parts, because I mentioned that I had this idea before. I sort of like earlier on, like a little while back, and so the first part of just getting like 2 points to get the closest spline location, that was done with just the draw debug. But I didn't like the rotation was weird to me. I was like, something's off about that, and I couldn't figure out what it was. And that's where I sort of ended up black holing on the camera rotation bit. But yeah, that was basically me getting one sound and realizing that there's something off about the rotation. So yeah, definitely start simple and take advantage of the draw debug. The draw debug is really powerful.
Yeah, I think for prototyping, like seeing that debug bool flag, yeah, sure, it shouldn't be there or whatever, but it is one of those ones where you help yourself by drawing more debug than you think, and then later on, a lot of the time, it comes back into a really good tool is actually very obvious to tell when it's not being a good tool, and that comes from debug. Like if it can't find a point, have the line change color, and if it found too many points that were the same, or if it's whatever, like usually the first pass at any system that I inherit is like adding more debug to it than instead of trying to optimize it, because don't optimize something or don't change the functionality of something if you don't really understand how it's behaving. And if you just have a line, or if you just have a sound especially, really hard to handle with debug, because is it right? I don't know. Like I've just got a number that says that I'm X distance away, or it's some volume or something.
Different kinds of things to debug, like there, you have the audio domain that you also may need some other stuff to make sure that stuff is working as expected, and then you have the gameplay elements, which is its whole other domain in terms of the kind of problems you need to solve and issues that arise. All right, cool. Well,
That's
we
great.
we ended up going over. Yeah, but it was the perfect amount of banter. Except Eric, you need to talk more. This is just the.
Hey, I mean, I'm here. I'm listening. I'm learning, and it's fun to look at someone else's approach to things and just follow along and learn. So it's always a pleasure to be on here, even if I'm not jumping in, and I don't know. I'll chime in if I've got a good question or something.
I think you have more good questions than you think. That's it. That's
okay.
But yeah, it's and that's why I liked revisiting this same problem space. I think that's one of the things that can't be overstated, is like how many different ways you can approach a problem, and the solution, different solutions for different contexts can be, more or less appropriate. And so there's a lot. I think it's fun to experiment, and I think it's fun to try, just try your ideas out. Just yeah.
I like it.
That's it. So that's the homework for everyone at home, or wherever you're watching this from.
There's someone remote working on a beach somewhere, like, yeah.
Well, that might be your home too. That's fine. Yeah, thanks for joining us, everyone in the chat. All the tips that we got from the chat, there was lots of good stuff from the chat, and yeah, thanks David and Eric. As always,
see you next time.
See you all next time. Whenever that is. See ya.